In this video, I'm going to look at some more examples of our composite functions. So the first example we have here is f of x equals the absolute value of x minus 4, and g of x equals 3 minus x, and we want to find f of g of x. So that means we want to take the inside function here, which is g of x, and substitute that into function f. So that means we're going to take the 3 minus x and substitute that over here everywhere there's an x. So we would end up with the absolute value of x, but in the place of x we have 3 minus x minus 4. And then all we have to do is simplify. So there we would have 3 minus x minus 4, and 3 minus 4, we would have a negative 1. So therefore, we would end up with negative x minus 1. And then if we look at this the other direction, so this would be your final answer. We cannot simplify this any further. So now if we look at g of f of x, that simply means that we're going to take the inside function f and substitute that into function g. So that means the absolute value is going to be substituted in over here for x. So therefore we would have 3 minus the absolute value of x minus 4. So again, all of this is going in place of our x. And then how can we simplify this? Well, in this case, we cannot take the absolute value of x minus 4 until we know the value of x, and the negative we cannot distribute, so therefore this would be our final answer. All right, next example. If we have the function f of x equals 3 divided by x squared minus 1, and g of x is equal to x plus 1. How can we find f of g of x? Well, once again, you're taking the inside function here, the g of x. It's on the inside, so we're going to substitute that into function f. So that means x plus 1 is going to be substituted in over here in place of x. So we would have 3 over, instead of x squared, it's going to be x plus 1 quantity squared minus 1. And here we could actually do a little bit of simplification. We could square this. We could leave it in this form. We could square the x plus 1, and that would become x squared plus 2x plus 1 minus 1. And then we could cancel the 1's out, so we'd have x squared plus 2x. Because here we'd have plus 1 and minus 1 to cancel. All right, if we look at this the other direction, g of f of x, well, that means we're going to again take the inside function, this time as f, and we're going to substitute that into function g. So that means all of this here, 3 over x squared minus 1, is going to be substituted in the place of x. So we would simply have 3 divided by x squared minus 1 plus 1. And that's basically your answer. Now we can get a common denominator here to add these together, which the common denominator would be x squared minus 1. So if that's our common denominator, this would remain 3 over x squared minus 1. And over here, we multiplied the denominator by x squared minus 1, so therefore we have to multiply the numerator by x squared minus 1. And therefore we would end up with 3 plus x squared minus 1, so 3 minus 1 would be 2, so you would have x squared plus 2 over x squared minus 1. And that would give you g of f of x. All right, one last example I want to look at is, what if we are given simply the graph of our functions instead of given the actual equation? So here, if we have the following graph, And let's see, it's going to have a sharp, some type of absolute value here. And we'll call this here the graph of function f, and over here we will have the graph of function g. So now all we have is the graph of our functions f and g, and we want to find f of 1 minus g of 1. Okay? So what does that tell us? Well, we need to first find f of 1. Well, that means we want to plug 1 into function f. Well, remember here, the 1, what we're saying is the 1 is our x value. So here, this is basically saying x is equal to 1. What does the y equal? Well, if we locate 1, here's 1, and then we simply go up on the graph until we hit the graph, and then we go over to find the y value. So here the y value is 2. So when x is 1, y is equal to 2. And we do the same thing here with g of 1, except for we go to function g, we locate where x is equal to 1, and then we go up on the graph, and once we hit the graph, we go over, and we find our y value is 3. So therefore, we have 2 minus 3, which equals a negative 1. All right, so let me give you an example for you to try. Say we want to find f of 4 multiplied by g of 4. So maybe you can pause the video and see if you can work this out on your own. All right, hopefully you were successful with that. If we want to find f of 4, again, that means that our x value is 4, and we want to find the y value. So if we go to function f, here's our x value is 4, and we go up to the graph, and we go over, then our y value is also 4. And that's going to be multiplied by g of 4. So again, we're going to go to function g. When x is 4, well, we're right here. When x is 4, our y value is 0. So 4 times 0 equals 0. Now, one last one I want to look at is see if you can figure this one out. We want to look at f of g of 2. So here we have a composite function. So we want to start on the inside, g of 2. So this is we're going to go to function g, and we know our x value is equal to 2. Well, this is where 2 is located. And if we go up on the graph and we go over to the y value, our y value is also 2. So now we're left to find here f of 2. Okay, so g of 2, when x is 2, our y value is 2 over here for function g. So now we need to find f of 2, which that says we want to go to function f, locate when x is equal to 2. So again here, this is our x value. X is equal to 2. And then what is our y value? Well, x equals 2 is right here on the axis, so if we go over, the y value is simply 0. So f of 2 then would be equal to 0 as well. So if we want to find f of g of 2, basically that says you're going to plug 2 into function g. We get out the y value of 2, and we're going to take that number, plug it in over here to function f, and we get out a y value of 0. So when you're looking at the graph, all you're doing is finding the x value and then going to the graph to locate where the y value is at. So here you have 3 more examples of your composite functions.